So thanks everyone for coming. This session we are organizing in the morning. The conference opened by us coming together to solve an urgent problem around climate change, and we talked about. We've seen a lot of presentations so far, which are sort of at the frontier of using Earth observations for impact evaluations. And this session is sort of trying to challenge us further and sort of reflecting on a specific problem around measuring climate resilience, because there are a lot of investments that are being made for climate adaptation, for agriculture, to improve farmer resilience. And the question is always that as investments are coming in, how do you measure that those investment are actually impactful? And it seems like it is not as simple a problem as we think it is. And so the question is, what can Earth observations do for that? So essentially, it's a panel format. We've got a very multidisciplinary panel here. And as I invite speakers, I'll just give a brief introduction. They'll make a few points around about 5-6 minutes. They're coming from, evaluator perspective, from users of data perspective, data science perspective, and hopefully in the audience, we have a few folks who are also providers of Earth observation. And then so we'll get the conversation going. I'll ask a few questions, and we really are here to have a very open conversation about what do we need for that purpose, and what can Earth observation do, and perhaps what other elements need to come in. And perhaps today, we can also come up with a community who works together and has a consistent framework that we can apply in places. So that's sort of the objective. So hopefully you're all going to be able to participate. I will open up to questions for a lot longer than other sessions. So look forward to that. So I will open a little bit just to sort of get the framing ready. So this is the panel, and I think you can see all of us. I'll give a brief introduction. So essentially, it's about using Earth observations for measuring climate resilience, and also to evaluate climate resilience. So I just wanted to get started by conceptually what it means, and there's a lot of literature around it, that climate resilience is the ability to withstand and adapt to the impact of climate change without undermining your current well-being and also the future well-being. Future well-being being particularly important in the context of climate change adaptation, because you have to also see what happens to your outcomes as the climate changes, and it's changing dramatically for several landscapes. So that future piece is quite important. So looking at Alaush and Carter, with whom we have been working a bit, sort of, so you can see the blue line is sort of communities or households that are moving along a well-being outcome. The well-being outcome is sort of undefined. It could be yields, it could be income, it could be health outcomes. I think it could be multi-sectoral. And then you have a climate event, and then you sort of well-being drops. And that dotted line below is sort of your zero resilience line. So if you're not able to recover from the shock, you're sort of go down to that level and never come out. You could even have negative resilience where you dip down, or you go up and recover. And that red line reflects that recovery. And then, so you can define the resilience simply as the extent to which you were able to bounce back. And if you bounce back fully, you're fully resilient. You can even have a transformative adaptation and go above that line. So now if we sort of say this is how you measure climate resilience, now what are the measurement challenges? Also wanted to say that you can also consider the case where you have an intervention which is meant to improve climate resilience. What will happen then your red line is, say, the case without any treatment, and you can imagine another line in between the two, which is say, hey, you adapted some stress-tolerant rice varieties that we heard a lot about this morning. And so you would see that because of that intervention, you have improved yourself, and then you have several ways of comparing climate resilience and getting to the climate adaptation impact. So what number one you need to be able to measure is a climate event. So what can Earth observation do to sort of measure climate event? It seems like we can do a lot more there, but even there, it seems like there's a lot more refinement that needs to happen. So that's one question that I'll have for everyone in the panel and in the audience. So you need to have data on climate shocks, and mind you, also stressors, right? The graphic is very sort of specific. One point is a specific shock, but we all know there are actually stressors that are involved. And then you have to sort of track the well-being for households that bear the shock, so the red line, and you're looking at the trajectory. And note that as you're looking at the moment the shock happens, is also emphasizing the importance of the time period in which you make the measurement. Are you able to go at the time when the event, right after the time when the event happens? So which means, that's a little bit of a constraint when you're looking at doing farmer surveys where, things happen at a defined period of time. And then you need well-being outcomes for households that do not bear shocks. And then you also need some historical data to establish comparability. And if you have interventions, then you need data on communities that have the intervention also, other than those that don't. So that's sort of what it looks like in terms of all the requirements. And so where are the places where Earth observations can come in? Because you're talking about creating a better trajectory. So maybe there is more high frequency data needed. There is data needed at when the shocks occur, so more agile data collection. And I think that's my framing, and with which sort of opening it up to evaluators, Anthony and Juan, and to others who are using data at more precise level, and seeing where you are all with your work. What are the challenges and what are the opportunities, and then drawing from all of you in the audience. And we're doing this also because we also have a charge to measure climate resilience for Agra, where we are the learning partners, and many other situations. So Anthony, why don't I bring you in? Anthony is a senior researcher at Mathematica. He is a PhD in sustainable development from Columbia and uses remote sensing and evaluations. So if you can share some thoughts about challenges and opportunities in conducting impact evaluations.
So the perspective that I want to bring to today's discussion is as an evaluator who works with government and foundation clients to understand the impacts of their agricultural investments and programs. And what we found with a lot of our engagements is that it's oftentimes our clients that are driving interest in Earth observation. So I think it's helpful to kind of identify what are the key differences between satellite-informed monitoring and evaluation against our traditional bread and butter in-person household survey, M&E, just to identify from the donor's perspective as well as from the evaluator's day-to-day existence what those key differences are. So with these large agricultural investments, we're often interested in a pretty broad range of outcomes: food and nutritional security, household income, livelihoods, diversity of sources of employment. And so not all of those outcomes are measurable from space. And I think that there are various data products that get at a clustered level, like assets for individual villages. But if you have an intervention which is diffuse, it's not specific to clusters, then you're not going to be able to use satellite imagery for detecting households that are beneficiaries from households that did not receive a set of services. So there's going to be some outcomes which require the continuation of that in-person data collection or SMS-based data collection. There's also a key difference in terms of the temporal dynamics of data availability and when it gets collected. So I'm going to make a provocative point here where traditional based M&E is really looking at changes over time. We want to identify from baseline to endline or baseline to midline. Did your program improve income? Did it improve food security? I think that a lot of the applications which have been well published in the ag space that use satellite data has really been cross-sectional. There hasn't been as much of a push in thinking about panel dynamics as has been the case in monitoring forest change or some other environmental indicators. And I think one of the factors is that in-person data collection to validate that panel aspect of satellite-informed analysis has often been lacking. There's big benefits from a timing perspective that really are a boon for donors and for the evaluators of these interventions. So under traditional M&E, your cadence is really restricted to when enumerators are in the field. And so if there are aspects like geopolitical shocks, natural disasters, pandemics, you pull your enumerators out, you essentially are getting no information from the field about what's happening at that point in time, and satellites offer continuous observation over that period. Lastly, from a marginal cost standpoint, sending folks to new villages to collect data from additional households, that's a relatively high marginal cost. whereas you have global coverage with satellites. So from a financial standpoint, there's also a key benefit there. Now, moving over to the challenges from the enumerator side, I'm going to echo some of the things that Ariel mentioned in today's presentation and was also discussed yesterday. And I think some of these challenges are shared equally amongst many of my colleagues here on the panel. The first one is that we are working with local data collection firms who often have limited GIS experience. So you can do your best in writing very explicit, comprehensive specifications. You can conduct back checks. You can have quality assurance measures in place, but that doesn't guarantee that all the data that gets collected is actually usable. So sometimes you'll get shape files back with polygons that are extremely long lines, really morphed, bubbly figures, things that are tens of thousands of hectares large, even though the plots that we're really collecting are on the scale of 0.5 hectare to 1.5 hectares. And what that means is a loss of data availability. So some of that data gets discarded, and that's a challenge from a cost perspective. A second piece that was alluded to earlier today is the prevalence of intercropping. So we conduct an evaluation for the Millennium Challenge Corporation in Niger, where intercropping is quite significant. In one of the locations in the rainy season, that's about 50% of plots, and in another location, it's about 80% of plots in the rainy season. The big problem is that we are still working with public 10 meter by 10 meter resolution Sentinel-2 data. And in these intercrop plots, you have spectral mixing, these mixed pixels where you're getting a combination of the spectral features of maize and sorghum, millet and sorghum. And the resulting output will depend on what those ratios are. 60-40, 50-50. So there hasn't yet been much of an advance in being able to understand the dynamics of those intercrop pixels, let alone guidance from a crop cut standpoint as to how you use labeled data from your crop cuts to then build yield estimation models. So this is a frontier area, which I think, given the prevalence of it, really deserves a lot of attention. A third piece is that several of the projects that we evaluate are focusing on the shift to high value crops for which there isn't a strong evidence base. So if you do a sort of Google Scholar search for crop cuts on tomatoes, cabbage, peppers, you'll come up short. And so what that means is for an evaluator, you have to identify what the spectral features are to train models. I don't know if that's necessarily the place that all evaluators should be on. There should be an evidence base that you can draw on to say, these are the key features that we see as being highly predictive in identifying for developing a crop type map or for predicting yields, those particular crops. On a related note, some of these crops are harvested multiple times per year. So instead of thinking about maximum NDVI within a season, now we're thinking about different processing techniques like cumulative vegetation index. The lift is probably not that large, but it's a change. It's a requirement that's not the case when thinking about estimating maize or wheat, some of the crops that there is quite a bit of research done and that's available. I think there's still some performance challenges. So folks can take a very optimistic lens when they see some studies that have high R-squared values or high correlation coefficients, but that's not always the case. You're going to be limited by the quality of your input data and other contextual factors. So one study that we had done for MCC on Burkina Faso, when we predicted out of sample yields and we bootstrapped this 10,000 iterations, we were getting mean absolute percentage errors on the range of 20 to 30% for some crops and 100% for others. How do you communicate this to your donors? How do you communicate this to the public? Another aspect is thinking about confusion matrices with identifying crop types. Ideally, you want to see really dark, bold colors on the diagonal. And when we see things off diagonal, we get concerned. There's misclassification. This is something new because when we're in that traditional M&E model, I ask you what you're growing on your crop. You say tomatoes, I report tomatoes. There's no confusion. Now we can start predicting in fields where we haven't collected data, but how do we then impute some of these misclassification errors when conducting economic analysis? So there's some major reporting and communication issues there to work through. I think there's a lot of promising opportunities. One issue that we're tackling through a consortium that MCC organizes with NASA and RTI is thinking about out-of-time predictive accuracy. So if you collect ground truth data in the year 2023, how accurate is it for predicting outcomes in 2024? In order to be able to test that, you actually need longitudinal ground truth data collection in order to verify this. And so this is based on work that we had done in Burkina Faso that we published last year, and a continuing work in progress to try to move those models forward. Lastly, another thing that I see as really exciting is some of the compilation and aggregation efforts that folks at Radiant Earth Foundation and NASA Crop Harvest have put together in pooling together training data to support model building for other folks. So if you want to build a sort of a crop type map, or you're trying to estimate maize yields, you're able to draw upon thousands or tens of thousands of samples through some of the databases like this. I think this is really exciting, seeing that degree of coordination and collaboration. So I'll pause there and then hand it over to Tomoko.
Thanks a lot, Anthony. So Tomoko, thanks so much for going next. Tomoko is at Precision Development. She's an economist there. And Precision Development is sort of doing this analysis from the other side. So you heard from Anthony, it does impact evaluations, and Precision Development is using evidence and data, and I hope Earth observations, to inform implementation of programs. So from you, if you can also talk about the challenges and opportunity of using Earth observations, and we'll come back to the question of how we can apply that to measuring climate resilience. So over to you, Tomoko. Do you have that?
Thanks, Tulika. So I will briefly talk about two use cases for Earth observations for impact evaluations. But just as a quick introduction, Precision Development, or PXD, is a nonprofit that uses scientific insights and evidence to design customized services for smallholder farmers. And digital agricultural extension has been a big part of our work. So the first example is a randomized evaluation of one of our digital agricultural advisory services in India, where we are trying to use satellites to construct a measure of rice yield at the smallholder farmer plot level. And in general, one of the big challenges of these evaluations of light touch interventions like digital agricultural extension is that you need a very large sample size to be able to detect an effect on downstream noisy agricultural outcomes. So using satellites is a very attractive, approach, because you can potentially measure impact over multiple seasons, which of course increases power, also allows you to look at the outcomes under different weather realizations with minimal to no attrition at a reasonable cost. So all sounds great. In practice, we are finding a number of challenges, and in particular, let's say obtaining consistently good ground truth data across multiple seasons, as you mentioned. And then I think actually figuring out which data gives us the best estimates of impact parameters we are interested in have been quite challenging. So just a couple of concrete examples, take plot size, for example. Of course, we thought GPS-based measurement where enumerators walk around the plot boundaries and then we corrected them based on satellite images would give us the best measure. But we're actually finding that we get a much more sensible distribution of yield when we actually use self-reported plot size. And we haven't quite figured out why that is. It might have something to do with the fact that, sometimes farmers change actually the proportion of the plot they use for rice cultivation from season to season. So that's one example. And then second, maybe I'll talk about the vegetation index. I think this came up in the previous session as well. I think one inherent challenge of using satellites for yield measurement in evaluations is that the vegetation index captures yield signal only through biomass. But increased biomass is not the only mechanism through which farmers can increase yields, right? So, for example, my understanding is that even improved seeds sometimes could increase yields without increasing biomass. So that wouldn't be captured by satellites, right? So then if you end up somewhat inconsistent results between self-reported and satellite-based yield measurements, it's not always obvious, which would give you the better measurements. So in this particular case, our plan now is to combine the self-reported and satellite-based yield measurement and just construct one aggregate index as a primary measure. So these are just a couple of examples where, what we might typically think would, obviously give us the accurate and objective measures using Earth observations might actually not give us what we need to generate unbiased impact estimates. So let me just move on to the second example. This is more directly relevant to climate resilience outcome measurement. So this is an impact evaluation of a financial product that increases access to water tanks among dairy farmers in Kenya, where farmers typically struggle to get enough water for their livestock during the dry season. And one big advantage of this evaluation is that we already have access to frequent agricultural outcome measurements, which is how much milk farmers produce and sell to the local dairy cooperatives. And then we get administrative data access through co-ops. On daily milk transactions. So it's a very granular data. So what we would like to do is to use Earth observations to identify geographic variations in the occurrences of dry spells or exposure to microclimate shocks. Right? And then we would follow what happens to the milk sales between the treatment and control groups immediately before versus after the dry spells. And then I think that the biggest challenge here is that there isn't really an obvious definition of dry spells that is appropriate for this particular intervention. So it's different from floods or droughts, where there are technical definitions that most people agree on. Right? So we are taking a data-driven approach and looking at the historical relationships between milk sales and the local rainfall to see if we can come up with a reasonable threshold to use. But this is something that I would actually love to hear what other people have done in these cases where they are looking at microclimate shocks that are not well defined in the literature and somewhat continuous. And you can imagine this challenge kind of applies to a lot of different climate adaptation technologies. Right? All right, so let me just and this was a very quick summary of 2 examples, but I just wanted to end with some ideas of the types of resources that might help organizations like PXD and researchers to use Earth observations better in their impact evaluations. And I think maybe one thing to add is that I think there are many different considerations, as you also pointed out, in using Earth observations for impact evaluations, as opposed to using them for cross-section analysis. And I don't think, from kind of an implementer/evaluator perspective, I don't think these differences or considerations have been really articulated. And that might be an interesting discussion as well. So maybe I'll stop here.
Thank you so much, Tomoko. Lots of interesting insights, some commonality on this piece around panel versus cross-section, and I'm glad you touched on measuring the climate shock. So we'll come back to that. So Juan, if you can, another impact evaluator with AIR, and I think you're the managing economist there. So if you can bring your evaluation perspective, and I think you're going to say a little bit about what role extension officers could play.
Thank you. Yes. I think we all share from the different presentations about all the potential benefits, right? In terms of using this or Earth observation for many of these impact assessments. the fact that we may have large sample sizes at low cost and going to hard to reach sites. Even for adoption of some things that you can observe, having even a more objective way of measuring those practices, because sometimes even for some practices, when you ask a farmer, did you apply this particular practice, they may not recognize it by name. So you may end up with a weird data where you were sure that people were actually applying what they were supposed to apply, and they say no to the question. So in a way, using this more objective measure could be good. And another thing that is actually I find very interesting is that because we want to measure yields, right, and that's production over area. Even the fact, although Tomoko made a good point, but even the fact that you think you can more objectively measure areas, right, in order to calculate yields is a good thing, especially in countries where the reporting of those areas are challenging. And I'm thinking of you, Ethiopia, with your crazy measurements. But of course, that doesn't come very easily. It comes at a cost. And some of the things, as I was saying, adoption in many of these interventions that are packages of things includes many, many different things, right? So there are many things that you are not going to be able to observe with satellites, which means that we are going to have to complement the information from satellites with surveys. So it's not that we are going to stop doing surveys, as I think many of you have been pointing out in your different presentations. And I was also going to say that, of course, we know that it's hard to measure agricultural productivity of some particular crops. And this is the point that Anthony and Tomoko were also making, right? I think it is very clear for interventions where you want to see what happens with the major cereals, right? But we see a lot of interventions these days that are promoting increased nutrition and healthy diets and things that are like they're diversifying the type of foods that people eat, and how that is also affected by climate change, and that may have we may have a much more difficult time being able to capture those effects for those particular types of crops. And then the point that I think Anthony made a very clear point, and also Ariel this morning, about in many of sub-Saharan African countries, we have all these intercropping systems that are would be really hard to measure with Earth observation. Now I'm gonna go back to this point that was what Tulika was mentioning before, which is, of course, in order to be able to make the best use of the satellite imagery, we want to train these models with reference data. But for resilience, ideally, we want to have continuous measurements, and that would be the very cool thing to do, because then you don't have to send the enumerators, right, multiple times a year, but really being able to take advantage of this. But you need to train the models, and for that, the question is how you are going to get that information. And one of the ideas that we wanted to kind of put out there is it possible for get the extension agents that are already in the fields to be able to provide this type of information in order to keep training the models? And for that, I wanted basically to mention two different things. Of course, on the positive side, we have in many of the countries where we are working on, we have these very well-established extension systems, right, of extension agents that are responsible for communities, and they know really well the area, and they have been well trained in the agricultural characteristics of those areas. So in that sense, it could be used. In some countries, extension agents are already using smartphones to disseminate information, so they may be able to be trained to capture some information and send it back in order for you to use it. But really, that's on the positive side. But I think there are major constraints for actually trying to get reference data from extension agents. In many, and I'm giving a lot of examples from sub-Saharan Africa, because that's most of the work that I do, but the countries that I know. But in many of those sub-Saharan African countries, the extension systems are underfunded and they are overworked. So these people, they are responsible for major areas, tens of thousands of farmers. They don't even have time to relate to each one of the farmers. And then what happens is that, and they are also doing a lot of administrative activities. So really the time that they have face-to-face is difficult. So it would have to be for a new type of extension agents and new cohorts of extension agents that could play this role, but it would be challenging to actually think that this is feasible. And then the other thing is that in some particular countries, the young generations are not that interested in working in agriculture. And you see actually in the composition of the extension agents, and in some countries, you see that most of them are male, close to retire, with very little interest to work with technology. So I also see that as a potential limitation to also use this type of agents, which would be great because, again, they are there in the field, right? And they have the knowledge to do a very good crop cut, right? But at the same time, in some of the logistics, there are major issues. So I'm gonna stop there and give the floor to.
Thank you so much, Juan. And Johanne really brings the interdisciplinary part to the panel. She's a quantitative ecologist. She's a consultant with CGIAR. And also on the standing panel for impact assessments, I believe. And very importantly, you brought together a paper that you're going to speak about that brings lessons from remote sensing. So looking forward to hearing from you on the opportunities and challenges.
So yes, my name is Johanne Pelletier. I work for the standing panel on impact assessment, which does a work of evaluating impacts of innovation that are developed within the CGIAR. And so we just released guidelines for providing a set of best practice and experience for the use of remote sensing for impact evaluation in agriculture and natural resource management and environment. And so the input I'm providing today comes from these guidelines. And so what we did for this work is to synthesize the insights of 11 case studies, which are research projects that are evaluating innovations of CGIAR in different countries, so mostly in Asia and Africa. And those projects are evaluating adoption, outcomes, or both. And so it's a different set of projects that are looking at innovation that is directly or indirectly related to climate resilience. So it's intended as a broad audience to really bridge the gap in between disciplines. So like limiting technicalities and stuff, and identify benefits and pitfalls. And so I will talk you more about this. So definitely it's a bit redundant from other presentation in terms of benefit. So the potential, I think we see it because the remote sensing data is available. It's getting more accessible, but also at higher resolution, higher frequency. There's always satellite being launched. And so definitely benefits that we see is in terms of spatial coverage. So definitely it's good to cover areas that are remote, conflict areas, or also area that would be very difficult to access, and including spillover, things that have not been necessarily targeted by any intervention, but there's some adoption elsewhere, so that we would be interested to see it, and using remote sensing can help us doing that at low cost. Potentially. So there's a long time series of remote sensing observation with 50 years of Landsat, 20 years of MODIS. There's, as Ariel said, it's collected repeatedly, regularly. So it's good for building panel data. You can have more consistent or standardized measurement compared to asking, a memory bias in survey or a recall bias. So these manage to avoid some sort of bias that you could find in surveys, but comes also with other challenges. There's also diverse measurement that's coming from LiDAR, radar, that measure different aspects that can be complementary, both between themselves, so different type of sensors, but also with complementary to traditional survey data. And so there's more availability for free and public access. But there is definitely important challenges that people need to take into account. This is not minor, and it's really in terms of the implementation, it's important to note that, like, for the 11 case studies, the most challenging aspect was obtaining sufficient amount of reference data, so information about the ground conditions and the quality. So this can be for different reasons. It can be the costs, it could be a crisis, for example, the pandemic that disturbs, or could be a conflict zone that happens, or a disaster that prevents the team from going to the field. Or it could be also constraint in data ownership, so obtaining the data from someone from an organization that provide information but doesn't want to give the geospatial information, or there will be some offset that's provided in the geospatial data, so that can affect result and usefulness. There's also just sometimes deficiencies in the planning. So field data, it happens, like Anthony mentioned, when it's collected by another organization, that you don't control what is being collected and how. But it could also be they collected points instead of collecting the perimeter, and that affects accuracy. So there's also a lot of error that can come from training data and validation data. So there's also the case of projects that want to use existing off-the-shelf products. Sometimes it's the understanding of how this data was generated, what definition was used, that can pose a problem for depending on the relevance of the product for the goal of the evaluation. So that's there can be not comprehensive enough, or not relevant. In terms of Earth observation data availability, definitely cloud coverage is a problem. Sometimes you will assume that you will have information for an area that's a high frequency, but then cloud cover limits your observation in reality. So that's a challenge. There's still a challenge with accessing very high resolution imagery. The cost is a problem, I see, and definitely that will be one of my points. It's a limitation that could be overcome possibly by institutions that are present here, or help overcome this challenge. For the more other challenges are more project specific. So for example, in terms of pre-processing, one of the projects managed to get access to a lot of very high resolution data, but then they were not well pre-processed. So thousands of very high resolution imagery to pre-process correctly for the analysis becomes a data analytic problem. So there's also combination, the fact that some measurements, especially for adoption, there's no methods that exist because it's very idiosyncratic of some project, and so there's no method, so it needs to be developed. There's also uncertainty and error. If you develop a map that has some accuracy, like 70% accuracy to measure conventional tillage and zero tillage, then and you use it with another product that has another accuracy, so it propagates the error. So at the end of the day, it can really affect the value of remote sensing derived products for impact evaluation. And there's my last point is in terms of variability between landscape and how it can be transferred. So even within project, people notice that in different landscape, you could have different results, different level of accuracies. And so definitely this is a issue because it doesn't mean that the method is necessarily transferable at the same level of accuracy elsewhere. So thank you, and I'm looking forward to discuss more.
Thanks so much. And Sean it comes from CEGA, where he is the project manager for data science for development. And thanks so much to the speakers before. And there was a lot of reflection on challenges. Hopefully, you can speak more about opportunities and make me feel a little bit more hopeful.
Great.
Go for
Thank you
it,
so
Sean.
much, Tulika. I want to start off by saying thank you to our Mathematica colleagues for organizing this panel, organizing us. It's terrific to be here. So I'll start with some exciting trends. So this is a little bit of a repetition from what other folks have said, but you know, there's been a lot of advancement in the science of Earth observation, showing that satellite imagery can be really useful for predicting a lot of different things. Some which are sort of expected things that you can physically see on an image, like crops, agricultural yields, forest cover. But more recently, there's been really exciting social science and natural science research that shows you can actually predict wealth and poverty, health and living standards, infrastructure, population density, and even automated plot perimeters. So that sort of is really exciting and opens up a possibility for being able to have more frequent and granular insights that folks can use to make decisions, better decisions. So going into the optimistic part of my remarks, I think a lot of the energy right now is around, you know, what is the best way to learn from this data? So I'm sort of echoing Ariel's talk this morning. And importantly, how can we sort of incorporate causal inference into these Earth observation frameworks? And there's a lot of exciting work in those threads. I think other folks have mentioned this. There's obviously a trade-off between sort of incorporating this data in the sense that it gives you more statistical power because you can sort of extrapolate to broader areas or maybe increase the resolution of the measurements you've taken, but it's not free, right? The satellite imagery is not error-free, so you might propagate more error, and it's difficult to get a sense of sort of what that trade-off is and when is it better to maybe not use the Earth observation data because it might be too messy, and when it might actually provide a lot of value. Some interesting work from one of our faculty affiliates, Robert Hellmeyer, and his co-author, they showed that there's actually a lot of bias in a lot of the measures for causal measures trying to measure the effectiveness of forest conservation policies due to the way that those folks set up the comparisons. So again, we're still sort of figuring out what are the best ways of setting up these comparisons, what are the best ways to model these different outcomes. And the more that we can sort of get into that complexity and differentiate, I think the better we'll be. And then again, this is, I think, will probably be the theme of the panel, but sort of change detection is the frontier right now. It's really exciting, but it's costly, right? We need to, in order to have long run assessments, we need to do long run surveys. We need ground truth data for multiple years, and that requires investment. So some challenges. On the research side, I think there's often sort of almost a fetishization of like your root mean squared error or your R squared, right? Like we sort of lose track of what the point of the research is. which ultimately is to help inform policy, help inform better decision-making. So what is a good enough model? What is a good enough prediction? Is an R-squared of 0.75 okay for us to make an actual decision off of it? Or is that, and I'm sure it will vary depending on what the actual application is, but we need to sort of center the conversation on how can we make this useful, and sometimes the perfect is the enemy of the good. And open data has enormous value in this space, because the more sort of these survey data sets and censuses and all the data that we're using to ground truth the predictive models that are using Earth observation, the better. But to go to the second point, that opens up a big Pandora's box related to privacy. So privacy, of course, is super important. And a lot of this data contains very sensitive information about communities and individuals. So we really need to develop good techniques to protect individual privacy. There's some really exciting work. One of my colleagues, Nitin Kohli, has been doing a lot of really great work around privacy enhancing technologies, where he's basically trying to measure sort of the trade-off between adding noise to data so that you can basically guarantee the privacy of the individual observations in a data set, and what the trade-off is for the accuracy of the estimates that you might derive from that sort of jitter data. And I think I got a question about this yesterday, about sort of like, oh, can you use, like, can you train an ML model if you have jitter data? And it's like, you can, but it's going to propagate more error. And we're still sort of figuring out what the trade-offs there are. And the better we can understand that trade-off, the better we're off sort of prioritizing the privacy of individuals, where in most of the contexts where we work are already living in situations of precarity. So we have, I think, an even more magnified responsibility to be good stewards of their information. And finally, there's an organizational question of what is the best way of making this information useful and accessible for communities to make their own decisions, right? So I put there avoiding the tyranny of technocracy, because you know, if I were to make a provocation, I would say probably if you took all the capital cities of Europe, San Francisco and New York, you would have like 99% of the data science expertise in the world, and probably 99% of where the data lives and, you know, where this information lies. So that's not great. That's not really, I don't think that's the type of model that we think will be sustainable. So we really need to think about, how can we expand opportunities for training so that more people can have the technical skills to do this type of analysis. As Johanne said, like, how can we make the satellite imagery cheaper so that or have differential pricing schemes so that folks that don't have as many resources can access them. And ultimately, you know, the world I would like to see is there's like a rural village head can go and has someone that can help them analyze in real time what the effect of an oncoming drought will be for their community, and then they go take that information and make a policy. And of course, even taking the global sort of inequality of this out, it's more likely than not, it will be in sort of capital cities in Latin America, Africa, and Asia, where the folks that are going to be using this data and these types of analyses are going to be. And there's also sort of like difficult questions of power and privilege in that dynamic as well. So, and we shouldn't be silent on that. We should be trying to figure out how to make it better. That's all.
Thank you so much, Sean, for reminding me of yet another issue coming at us. Since you mentioned the tyranny of technocracy, I keep worrying about the AI models that are sitting somewhere, and it seems that the smartest people dealing with it don't know how they work. So we'll leave that aside. But you do bring a very important point, because you're kind of talking about locally led adaptation and how do you bring the data and information to the communities. And it's not just communities, right? Locally means local governments or districts. And at every level, how can you bring this complex information so they can make the decisions themselves? So thanks so much to the panel for opening with some really important remarks. It sort of centers the problem on some specific things you talk about, which is either you talk about reference data or, you know, the ability to, the capacity to have, to make those measurements. So if I look at the problem of climate resilience, it seems, measuring climate resilience, it seems like we look at few buckets, right? So it's how do you measure the well-being outcome? And I think we kind of all agreeing that the well-being outcome that Earth observation could handle is perhaps yield. But I do want to push the panel to think a little bit sort of beyond yield. I mean, there is, you know, in the, I think Andrew Foster made this comment about, can we just focus on yield, and is that adequate because profitability is important? But at the same time, there are precursors to yield. There are a lot of investments that are happening in improving soil health, in improving the landscapes, and all of those are meant to also provide resilience, not only just in terms of yields, but also general protection from droughts and floods and so forth. So I want to expand the orbit of well-being outcomes beyond that, and I'm glad to see that we have 8 data folks here, and Kuvar Singh is doing a lot of Earth observation, so you can also contribute to some of this. And we saw this piece and discussion around measuring soil health, and it seems like it is probably at the frontier of doing that. So maybe I will go back to you, Anthony, and Anthony and Juan, you can both talk about it, because let's start with yield for a second. And you raised a challenge about measuring yields of other annual crops, such as tomatoes and others. But in terms of food security, if I look across in terms of the major investments being made, it seems like, you know, maize and rice are important food security crops. So even for a moment, if you focus on those, and if you would look at the number of investments going into investing in drought-tolerant rice varieties, stress-tolerant rice varieties and maize varieties, it's a substantial investment. So if we can even move the needle on using Earth observations for measuring resilience, the resilience outcome related to those investments, that would be a plus. So let's hone in on, say, measuring maize yield or rice yields, and talk about some of the opportunities that Earth observations can have, and you're free to raise the challenges, and maybe we will invite some of the guests here to speak about the solutions to those. So do you want to say a little bit about measuring yield specifically, and if we can sort of narrow down the bucket of crop yields that we could focus on?
So like I mentioned in my remarks, I think that there's been a kind of narrow corpus of crops that have been subject to a disproportionate amount of attention in thinking about yield estimation models. So I think that's one factor to really consider, whether or not that's reflective of the sources of income that households that we're interested in measuring their resilience to climate shocks, and the reliability that we have in crops that are not included in that group. There's also this aspect that when we're measuring something with noise in the cross section and over a repeated period of time, are we just measuring differences in noise over a trajectory? So I think this is a concern, especially with like land cover products. So if you did just a year-on-year analysis and you found that this forested area turned into grassland, is it really grassland? I mean, if you really dig under the hood for something like a glob cover or some of these Modus land cover products, it's like a 60% confidence in that primary classification. Whether or not we want to put a lot of stock into that level of confidence in assessing somebody as having improved resilience or decreased resilience and the impact that that has for investments, that's a separate question. It just feels like there's a lot of this error propagation and uncertainty, and yet billions of dollars of investment that will go into R&D and deployment. So are we confident with that sort of ratio of noise to actual productive investment that has to take place? So I'll pause there and hand it over to Juan.
The focus on these cereals is still super important. For example, in many sub-Saharan African countries, this is, and in other countries in Southeast Asia, these crops are the most important crop, right, for these farmers. So concentrating in those crops is still very a key issue. What I think is important to know, and this is something that I don't know, is to what extent you really can train these models to deal with the intercropping of maize and beans or maize and cassava, which are basically, right, some very common practice in many of these countries. At the same time, I do see a good opportunity there, because even despite of the potential noise that you can get in measurement, the productivity of these crops, when you collect, we all know this, when we collect data from farmers and we ask in the last agricultural season, how much did you collect in this particular area? And no matter how much effort you put in programming the software with pop-up windows whenever the response doesn't make any sense based on the area that they are reporting, and then it's really a clear wrong answer. It's just too many standard deviations above what is supposed to be expected. And when you plot that area, that information, when you get it, like, I don't understand how you took many steps to actually try to get very good information about yields, train the enumerators a lot on what are the typical values, and still the information is very, very noisy. So in that sense, I still feel that this is a very good way, at least as a complement, to have like a double check, being able to, as I was saying before, even able to check the areas and being able to see them to some extent, right? And make a judgment in terms of, okay, maybe the farmers are doing a good job in terms of, or is the fault of the enumerator, right? A lot of that information is actually is very helpful. So I see a lot of potential basically for these particular crops because of their importance, and to be able to complement it with the noisy farmer data.
So some agreement on that idea of focusing on a couple of crops. Just wanted to sort of remind ourselves that we talked about measuring yields, but in terms of resilience measurement, ideally you want to be able to measure more frequently, or at least right after the climatic shocks, to understand what the yield outcomes were related to that. So I'll combine two questions and I'll turn it to you, Tomoko, and then Johanne, from the research that you did. So one is that, to what extent in the papers that were sort of compiled or in other experiences or in your work, Tomoko, were you able to sort of get Earth observation data, say, on a panel where you're able to actually set up, you have your research area and you kind of want to go back in a repeated way, and is that possible? And I think Anthony had initially talked about the importance of doing that, of thinking about the Earth observation data that's coming in and how can we get organized around making sure the measurements are coming from the same area. That's one. And number two, since Sean mentioned that towards the end, that to not forget that there are other information that we can bring in, which can give us a better sense of the economic indicators. So that we're not stopping only at the yield measurement, but we are also, at least over time, beginning to understand what the broader measurements we can make, which can give us a better sense of the overall resilience, because there'll be others, economic outcomes are a big source of resilience. So if you can start, Johanne, about any sort of evidence you saw that?
Yes, definitely. So among the case studies we included, definitely there many projects take advantage of a long time series of data. Some innovations started many years ago, so it's advantageous to be able to go back in time for the same area, and it's like a time machine, and you can go retrieve information before your innovation was adopted and look after. But definitely the long time series is not necessarily available for the resolution you want, or there can be gaps. So definitely at this level also, if your innovation was implemented 10 years ago. You're more limited in terms of imagery you can use. Is it working?
I'm not sure. Are you able to get it? Okay.
Yeah, looks like yes.
Okay. So yeah, so definitely, and
is the reference data also a constraint because it's not just the Earth
Yeah,
observations, right? I mean,
exactly.
you need to have the
Uh-huh.
reference data from the same, from what I
This is-
understand, we are not advanced enough. When I initially started having conversations with Anthony, I thought, oh, reference data for one time period is good enough. I said, no, you need it
yes,
for
yes, and
every time period.
absolutely.
So any thoughts on why that's needed? And so is this like a call, I think, Sean, in your presentation, you talked about sort of having, and I think you mentioned it, having a coordinated effort around reference points. It seems like people are collecting it. I'm sure Edie has a ton of programs going on where they're doing crop cuts and across the board, if there's more we can do. So is reference points is probably a constraint.
That's a constraint that I'm sure people will
Yes.
agree with. Often reference data have been collected for 1 year, but then you want to see if you can predict not only in space but also in time, so you also need to have some validation in respect to that, and sometimes there's just no data available, or sometimes you can go for some application, use Google Earth and look at reference data there, but there again, in some places you can have one good image per 5 years, so that's not enough. Like, so if the availability would be more, and I think there's a whole data sharing discussion that, because a lot of the to really seize the potential of Earth observation, there's really need to be to have access to high quality and amount of reference data. Otherwise, we're like kind of getting like average model. And so we cannot benefit as much as if we can build the best.
Tomoko, do you want to come in on?
Sure. Yes, yeah, I do definitely see this kind of challenge of collecting, consistently good ground truth data. The first evaluation I talked about is in one setting where we collected actually 13,000 plot boundaries. So it's a good opportunity to do a lot of kind of modeling with Earth observations and collecting, from subsample of farmers, we're collecting self-reported data, and then we have much smaller sample where we are collecting crop cuts. We did that over 2 seasons. We are now working with the 8 data team, and the predictive power looks much better. But even then, the first year, I think this is primarily because we just didn't know how to, collect really good crop cut data. The predictive power is much lower. The second year looks much better. So that, I think there's a lot of learning curve in collecting ground truth data as well. So that might affect kind of the ability to do cross season comparisons and so forth.
Thanks. Sean, if you can come in on that point that I made about integrating other data. And then I want to turn a little bit to an area where I feel I understand reference points are not needed, which is measuring the climate shocks, which is also super, super important for climate resilience. So say a little bit about how much we can do to enrich and just speak a little bit about your work that you've done around that. And
Sure. Yeah. Thanks. Well, I mean, I want to give a +1 to the comment you made at the beginning of the panel of it, resilience. Yes, yields are probably the easiest and most visible form of measuring that, but how many assets someone has, and what is the situation of their health, and all these other dimensions are going to influence how much an adverse climate effect is going to affect them, both in the short and long run. So we might only focusing on yields is good in the sense that it's it's what is possible at the moment, or what's been is best understood. But as we sort of dig down into the complexity, we'll get a better sense of the variation of resilience if we can take in these other measures of social measures, demographic measures. And there's a lot of new research that shows that you can do a decent job, at least, of measuring poverty and wealth if you have good, high quality survey data for a place, and using satellite imagery, you can it's not perfect, it's not error free, but it's better than, the last time a census was done or the last time a demographic survey was done was 5 years ago. It's better than nothing, right? It's like we're in the land of marginal improvements. So if you can bring in that additional information to help you contextualize, which might be the places that are the most vulnerable, where, that I think that it could be really useful. Another exciting thing that's sort of happening right now is looking at the effect of anticipatory cash transfers. So you can predict adverse climate effects, for example, floods, and then in advance, you set some kind of threshold, like when the risk of the flood is 60%, we'll give the cash transfer, and then you can see sort of how people use those additional resources. Do they leave? Do they spend the money to protect their assets? And that can be another way of sort of shoring up resilience in advance of an adverse climate effect, shock.
Sean, could you say a little bit about, the measures that you're talking about with Earth observations or poverty? I mean, of course, poverty, we have much better data. There's a lot of measurement going on, but of course, the challenge is always in the small area estimation part if we are getting into narrow areas. How good is the measurement over time? Because poverty, some of these indicators that you're using are not going to, they're not going to move so quickly.
Yeah.
So how sensitive are these measures to smaller changes? I would imagine it's going to be a little bit more helpful in the before and after, but not quite in the in the shorter.
Yeah. So the level of resolution I've seen is like 1 kilometer squared usually. In terms of how resilient are the measures to change, I think there's two sources of decay. There's like model decay, where as time passes, the model becomes misspecified, and then sort of the things that you think are really predictive may not be as predictive anymore. And then there's also data decay, where the household characteristics, the actual people, are changing. They might be becoming wealthier, they might be becoming poorer, and if you don't collect data to validate whether those characteristics have remained the same, then you're not going to predict as well.
Okay. And you made a reference to the climatic shock, and Tomoko, you did too. And I think all of you kind of mentioned this, but so it seems like, if we are looking at, we focus a lot on well-being measures. And I'm also noticing in the conference, we're focusing a lot on measurement of, outcomes, final outcomes like yield using Earth observations. But hidden behind all of that is the measurement of specific climatic shocks. When are we defining when a drought occurs? When are we defining when a flood occurs? And especially when it comes to stressors, how well can you define, say, a heat impact? And so those are places which seems like, we can leverage that for EO, either to design solutions or to design, and I think in your case, you were really relying on Earth observation for measuring climatic shocks and then doing measurement of what happened to dairy sales. So you're sort of combining Earth observation for that purpose. So let's speak to that a little bit, and we'll go to adoption. I do want to open it up because I know people in the audience have a lot of questions. So just very quickly to you, Anthony, on measurement of climate shocks. And
so I think it's really important to have impacts scientists who are involved, who understand the data generating process. So if we're thinking about agricultural outcomes, it's agronomists who understand what are the key weather features that cause yield loss or other issues. And so you can take a kind of slim, simple approach of just like basic NDVI and see, like, does this correlate well with maximum temperature over the season? But the better agronomically informed approach is accumulating harmful degree days and growing degree days and thinking about buckets. What this requires is expertise. You need to have the scientific disciplines in the room who have their own modeling approaches to be able to then ingest the temperature data, the precip data, humidity data into identifying and converting, has there been a climatic shock or not? One of the things that we've faced in some of our WASH evaluations is trying to translate precip data into flood exposure. Now, flooding is something that's notoriously difficult to measure because A, it coincides with lots of cloud cover. So from an optical imagery standpoint, it's difficult to detect. As well, floods are very short-lived. And so a flood event could last for 3 days and be completely missed by sentinel imagery. We also see that there's a big discordance between households that live next to one another and their self-reports of flood exposure. This doesn't make any sense. We take a look at topography, we look at slope, we look at DEMs, all these features that should explain differences in flood experience, and it just doesn't connect to the self-reports. So I think that it would be great if we could get all the disciplines on board to be able to then translate models that convert the basic metadata into impact exposure, but we're not yet fully there. I think that the teams need to be formed, the objective recognized, and I think that we're still in early phases in having confidence of being able to construct like a binary yes, no of did this person or plot experience a climatic shock?
I realized that I have much less time than I had thought of. So I think we end at 5. So I want to make sure that I get some questions in from our audience, and particularly on these general themes of measuring outcomes or measuring climatic shocks or even adoption, which we didn't get to even. Please do introduce yourself and ask the question and name the panelists you would like to.
Sure. I'm Elena Serfilippi, working at the Committee on Sustainability Assessment. So I think thanks a lot for the interesting discussion. And actually, just one clarification about resilience measurement. As we say, so we are measuring only resilience as well-being. Actually, no, the definition of Carter is considering resilience as the individual probability of reaching a determinate level of well-being, and how these can be deviated by some shocks. And the well-being, we said, that is yield, and we can monitor yield by Earth observation. But there are a lot of folks in this room that are measuring resilience in other ways, like a set of capacities to absorb the shock, adapt, and transform. So maybe we can think together how to apply Earth observation to measure those capacities, because sometimes the intervention of development practitioners are really developing those capacities, and then the final outcome is the yield. And so, yes, this observation I wanted to share.
Oh yeah, thanks for mentioning that. And I should have opened my remarks by talking about the measures of resilience, and actually how there is not that much difference. So I think the resilience is defined as the ability to adapt and withstand climate change. And I think even the literature that measures adaptive capacity, absorptive capacity, transportive capacity is talking about also the realized resilience, which is how did you actually indeed do. So I think we're focusing a lot on that particular portion of it, but you're right, but you could just look at, well, how, the capacities that modulate that resilience, what does that look like? And I think a way to get to that is adopting the technologies that are being promoted by the intervention. So we kind of didn't get to that discussion also, that what are the ways in which donors and agencies, and what are the interventions that are being promoted, and what are the types of capacity that is going to change or modulate, which will eventually have an impact on stabilizing it. But I do think that the litmus test of whether that actually happened is important, which is why the focus on, well, did you actually manage to maintain your well-being or not, is also very vital. But thanks for bringing that so we could discuss this. We have a hand up, please.
Hi, thanks. I'm Romina Cavatassi, working in FAO in the Gender and Social Inclusion Division, but on loan from IFAD, where I work in the Research and Impact Assessment Division. First, I'd like to share a thought related to the fact that I've been working in this field and collecting data for 20 years. There's been a huge amount of advancement in technologies and data, but there are some issues that always remain, namely the intercropping, the land size, and you name it, but they're always the same, and it seems very difficult to address those to start off with the agricultural season itself. So defining what is the last agricultural season, it's already a challenge in many countries because of when it starts, when you collect the data, et cetera, et cetera. So I think the issue here, it's more how can we combine, what is the best way of combining what is available through Earth observation and remote sensing with what we still need to collect. And I think Juan shared a very useful idea that is to tap on the knowledge and presence of extension agents because they always are the repository of a lot of information. They know the communities. I remember in old days, there were tons of papers in their offices with data that were never used. And perhaps now with smartphones or tablets, a lot of that can be done, can be collected in a monitoring system in a much more systematic way. So that could be one way to combine the data, for example. And the other thing is on what Elena just raised on resilience, I think there is I always struggle with this because on one side, there is the resilience building, and that's related to building the capacity, which is largely related to adaptation to climate change and climate shocks, because as you said, there are stressors and shocks. But then there is the actual resilience. And so that is, okay, you build the resilience, but when a shock occurs, what happens really? Who is resilient and who is not? And there is still very little evidence available on that. We tried in IFA to build evidence on this. So for the projects that were part of a program of work called Adaptation for Smallholder Agricultural Program, a number of practices have been promoted. Of course, adaptation is also very complicated because it's context specific. Every situation needs a different type of adaptation option, etc. But at least going into the specificity of what was promoted in each project, we tried to collect for those farmers that had adopted those practices, because not everyone adopts what is promoted, or maybe they adopt a subset of what is promoted. So it's very difficult to collect that evidence. But then for those, when the impact occurs, and we do have satellite data that can help us when the shock really occurs, then we can measure the yield and see, are they more or less resilient? So I think we need much more of this type of evidence to be able to say what works and what doesn't work where. And that is still largely lacking. Thank you.
Yeah, I think we agree, which is why we're trying to come together. Thank you so much for your remarks. Anybody? There's one over there question, and I think we'll just take more comments rather than responding to them, because I think you're contributing to the conversation. Did you want to go next and then go to you?
Thanks very much. So I'm Pierre Sibiri Traoré with ICRISAT in Senegal. I like to be provocative, and
Yes.
when I think of ground truthing, to me, it's a little bit reminiscent of navel gazing. It's really about thinking of how you improve the EO product. And I would rather think of space truth as a way to understand the ground lies. And what I mean by this is that in smallholder agriculture, variability inter-farm in management is the main determinant of variability in yield outcomes. And I think we spend still too much time in trying to predict yield outcomes from remote sensing using a rather reductionist approach. I think there's too much focus on also thinking of EO as a substitute technology rather than a complement. There's also too much focus on trying to use it targeting directly the end user or the last mile, as opposed to the next users who actually have agency to transform the systems. And I really see EO data as a tool that is actually used to increase the consistency in field data that will always be continuously required. One obvious example is fertilization, which is something that is extremely difficult to infer and which will continue to require proximal interaction. I also like to plagiate Holger Meinke in thinking of crop models as discussion support tool rather than a decision support tool. And EO should be thought of really like this in many ways. And another avenue that I see has a lot of potential in EO data is to help decrease the costs of field data collection, to support the development of business models, typically by privatized extension agents, to really bring to scale essentially proximal services that otherwise are not context specific and therefore not likely to achieve much impact. So really, I think this idea, I think that you raised, that remote sensing and Earth observation needs to spend more time on potentially monitoring or predicting the precursors of yield, is extremely valuable. I think that there is more scope for improvement in that sense, rather than trying to work directly on the yield outcomes.
And thank for your provocative remarks. I think they resonate a lot. I saw a lot of heads nodding, and I think even using climate shocks for improving our sampling so that we have enough people who had or did not have shocks is also another way to do that. But I would love to get your remarks and thoughts in.
Yeah, thanks, Tulika. But I think most of what I wanted to say has already been said. Sean answered my question even before I asked it, and then colleagues added to that. It's about how are we measuring resilience? You know, what are the indicators that we use? I think yield is very reductionist, if you ask me. So, and it's not an outcome, I think. So maybe we are actually, a piece of information is we are developing a framework and indicators. How do we measure resilience? And is it different for men and women? Because we say women are much more vulnerable to climate change than men are. So do those indicators differ, or how does resilience differ? So this is something we are actually trying to generate some evidence on in the CGIAR, part of the gender platform. So we'll be happy to share that with you as it comes up. And then maybe we can't measure all that with the Earth observations, but then it's going to be a combination of EO plus survey data and so on. Thank you.
I just want to acknowledge that we have a question online. Are there examples of using EO to track the adoption of regenerative agricultural practices? According to Descartes Labs, this could be a pragmatic opportunity given the movement to RA practices by private sector partners. This is from Dr. David Bergvinson. He also said, real quick, I know where the reason for my question is region ag tracking is important in that it's showing increased profitability and resilience to weather variability in African cropping systems.
I'm glad that question was asked, because I did want to get into this whole issue of, can we measure adoption? And I know some papers were related to that, but anybody in the panel or anybody in the room who can answer the question?
I can provide examples.
Please.
For example, the use of fertilizer tree in Zambia. That was it's one of way to improve management. There's also mapping of conventional tillage and zero tillage. And now I heard about the shallow tillage, which is another type that's been mapped recently by one of the case studies. So there's more progress in being able to measure adoption of improved management practices.
Nice to tie that to then measuring the overall resilience, but it sounds like the questioner did say that there was some measurement happen there. So I just wanted to say, as you were asking questions, and if the organizers could convey, if we can have the names of people who joined the meeting today, and if those who are interested in continuing the conversation, we'd be very interested in getting all of us together to continue to solve some of these interesting problems. So just wanted to mention that. You have a question, please, and then I'll get to you, please.
Well, thanks a lot for the very rich conversation so far. My name is Julius Adeopo from the International Institute of Tropical Agriculture within the CGIAR, one big happy family. I just want to start to piggyback a little bit more on the third provoking comments from Sibiri earlier. I know we haven't talked much about this, but there's a part where we started to do a lot of research. Well, there are more research now about how we engage farmers, how we engage households, and collect data that we can eventually link to, petabyte scale Earth observation data. Without this kind of data, coming in streams at a very rich temporal scale, we're still going to be lost as to what happened, when, how, and where. I remember one of the conversations I had and I'm giving you context here. I remember one of the conversations that I had about 5 years ago with Google folks out of San Francisco. And we started to talk about this, I tinker with this idea of universal crop collector, essentially thinking about how do we engage citizens to report data, on what's even on their farm. I've seen a couple of research that are geared towards discrediting farmers, saying that, can we trust farmer reported yields? Can we trust farmer, she said, he said, just like we heard in previous session. And I just think that maybe we're missing a big piece of what should be the next level of a data revolution to enrich Earth observation data and to unlock the insight from it. Without truly engaging citizens and the people who are the users, and I think the custodians of data, we will never get, I think that we will never get to a place of truly using and leveraging Earth observation data the way it should. I think to wrap up sort of where I'm going with all of this, are we now missing something important by not really giving more credit and building systems that allows us to trust and validate? In compliance, we use the word trust but verify, but trust and validate what is coming from the citizens so that they're not just end users of data or next users of data. They're part of the data ecosystem. They're part of the data revolution. They have a sense of ownership, and by then, I think way into the future in terms of a long-term vision, we can truly leverage the power of citizens, being able to become a solution for the problems we seek to solve with Earth observation. It's a comment, but also a question to the panel.
I don't know if anyone has any inputs on that, but just wanted to say one thing that we did, as Sean, you will have something to say, it seems. We did a scoping review for the locally led adaptation group in the Global Center for Adaptation. And in the context of measuring resilience, this idea of citizen science did come up. Very much so, because we're talking about high frequency data, we're talking about collecting data around how people are experiencing the shocks, or rather the time at which it has to be collected. So there is actually some amount of synthesis of where all it has happened so far, and I think there is a lot of interest in using citizen science, and then we can use our approaches to address the bias, if any. But Sean, you wanted to
Yeah, I just wanted to say I really appreciate this call. Like, I think participatory data collection is a great opportunity and something that we underutilize. I will say that there's a lot of ways that participatory data collection can be very difficult to pull off. I'll give you one concrete example. We're testing a model in Rwanda that will automatically delineate small land holdings. And we thought, okay, great. The model will predict the plots, and then we'll send out enumerators to these communities, and then the farmers will look at the plots and be like, oh yeah, this is my plot, this is my plot, this is my plot, perfect. And then our partner on the ground was like, no, that's not gonna work. People don't know, they're not used to looking at maps. They don't use maps, right? So figuring out the right sort of the right language to tap into the knowledge that those folks have it remains a challenge, and we're not equipped to do it because we don't know the places well enough.
for one more question at the back, or?
Sure. Yep. And then I just have a couple things to mention before everyone jets out of the room. So thank you.
So I think you were next. Please go.
Thank you very much for giving opportunity. I'm Ajit Nan from Pantnagar, India. And I really appreciate the remark of the gentleman on citizen data. I also wanted to make comment on how important that crowd data is. And in my opinion, that we should really think of using this crowd data, but with the filters, because not every information which will come to us would be useful. So would be very important as to what is needed and what is not needed. So that would be very, very important for impact analysis. And fortunately, we have recently initiated one program in which we are trying to capture the crowdsourcing data from the farmers. But then we have certain riders and certain filters which we had applied. We have enrolled the farmers, and then the kind of information which we need that form has been circulated through Android application. So the Android will again be very, very important tools and techniques in the days to come. We are using this Google Lens for identifying the different objects. So similarly, we can use the Android capacity and capability for identification of the different crops, and especially when you raise the question that how this intercropped region can be identified. So I believe that this Android could provide a solution. The second thing is that tons of the data that is available with the different government agency. If you talk about the government of India, every year massive drive of crop cutting experiment is not taken by the governmental agencies. So that data can also be used for our impact analysis. Another thing which I would like to raise is that when you are doing impact analysis, quite often we take a very straightforward route, but I believe that we should also look at the other offshoots of impact studies. For example, government of India has imposed ban on burning of the rice residue. But I believe that it is not only that when we are sensing it through the Earth observation as to how many area has been reduced, but it is also that how many potential area which would have been converted but not converted because of the Earth observation system and the government policies. So this offshoot should always be taken into consideration when we are talking about the impact analysis. So thank you very much for providing opportunity.
Well, thanks so much for your comments. It sounds like you're thinking about the right things and generating lots of useful data. So should I close it?
You can conclude, and then I just have a couple things to mention.
Well, thanks everyone for all your comments and listening to the panel. Just organize this because of the realization, as I mentioned, of so much investment going into improving climate resilience, yet we don't really have a baseline on what that looks like in terms of targeting or evaluating. So for all those who are interested in continuing the conversation, do reach out to us, any one of the panels. We hope to stay in touch and continue to force the path forward. Thanks so much again.
Thank you.